Yes, good evening, everyone. Am I audible? Please let me know in the chat box. Yes, good evening, everyone. Am I audible? Please let me know in the chat box. Yeah, give me 1 second. And I hope everyone is ready for this problem solving session. Yes. So again, the same pattern as we have discussed in the previous sessions also, right? So I will be sharing you the problem and you will be having a timer. So in this particular session, let's increase the timer. So previously it was only 1 minute, right? So let's have it for 3 minutes so that we can you can have some time to solve the problem. And before going to start the session, any doubts or any queries in the previous test which I have shared you previously? The Google form in that particular test. Anyone having any particular queries or something, please let me know. I hope everything it is clear, right? In that particular thing. Okay, that's great. So then let's start with this particular session. So let me share my screen. I hope my screen is visible, right? Okay. So here comes the problem number one. Yes. So this is your problem number one. So your time starts now. You can take basically 3 minutes of time and you can basically solve this problem and let's discuss the solution. Okay. So let's say suppose if A is equal to 0 in the logic expression, Z is equal to A plus EF plus B complement C plus D into the expression. What is the solution which we are going to get? So take your time, solve this and let us discuss the solution. Okay. So your time starts now. If A is equal to 0 in this particular expression, then what is the value of Z? Is the question. Okay, got one answer. It's option C. Okay. What about others? Option C. I can see few people. Okay, let me open. What happened to this clock? Okay, I can see few people giving answers. Okay, so last 1 minute left out. Please try it out. Give me one sec. There is small mistake in the problem. Actually, it's D bar F bar. One second, let me change the rearrange it. So it's basically D bar F bar. One second. How many of you getting the answer? This is D bar F bar. So now solve it. Option C you're getting. How you're getting option C? So the question is D bar F bar. The last term is D bar F bar, not D E whole bar. It's D bar F bar. Now solve it. Okay. So let's see the solution. I hope you're also solving. Let me also solve this question parallelly. From next question onwards, we will have the time. Okay. So this particular term, which is A plus EF plus B complement C plus D, we have right, into A plus DE whole bar plus B complement C plus D bar F bar. The question is wrong over here. It's D bar F bar, right? Now, what I'm going to do is I can basically write this. Sorry, this is also wrong. It is D bar E bar. It's not DE complement. Please correct this one. It's D bar E bar. Okay. Now, what we can do is we can take D bar common in the second term. So it is nothing but A plus EF plus B complement C plus D into A plus B complement C plus D complement. If I take common, it is E complement plus F complement, right? Now, what I can do is I can basically, I'm going to group these two terms. Why I'm going to group it, I'm going to let you know in a few seconds. Plus EF plus D. And I can also have A plus B complement C plus, if I apply De Morgan's law over here, it is nothing but D plus EF whole complement. Okay. Now, what I'm going to do is I'm going to consider this A plus B complement C as M and EF plus D as N, so that I can rearrange this whole term as, so what I can do is I can rearrange this whole term as simply Z is equal to M plus N into M plus N complement. Okay. So I'm basically assuming this term as M and this term as N. So it's M plus N into M plus N complement. Now I can solve it easily. So which is nothing but M plus N into M plus N complement. It is nothing but M plus Mn complement plus Mn. And I can take M common, which is nothing but 1 plus N complement. So which is nothing but M. What is my M value? M is nothing but A plus B complement C. So M is equal to A plus B complement C, which is if you substitute A is equal to 0, you're going to get M is equal to B complement C. Yes. So it's option number C. Okay. I've seen few people getting the same answer, option number C. And what about others? Are you getting the same thing? So it's option number. Hello? Are you getting the same thing? Okay. Give me 1 second. What happened to this? Let's see one more problem. Same thing. Yeah, yeah, sure, sure. 1 second. Yeah, please look it. Okay. Shall we move forward? Am I audible, right? Yeah. So let's move forward and let's see the next question. So this is your question. Take your time. You can take 2 minutes of time for this, and let's have it. Anyone getting the answer? Option C. Okay, I got one answer already. Option C. Okay. So let's see how to solve this particular question. Others also please try to answer it. Now, what is that our question? So our question is we need to find out what is the value of A and B. For that, my input will be equal to 1, right? Now, that means our output is clear. Sorry, my output should be 1. I should find out the input combination. So here my output is 1, right? Now, if my output of AND gate is equal to 1, that means we already know that input should be 1. So this is equal to 1 and this is equal to 1. And output of NOT gate is equal to 1, that means input should be 0. Okay. Now we have got this particular combination, and your particular input of one of the OR gate is 1, and other gate can be anything. It may be 0 or it may be equal to 1. Let's say if this is equal to 0, one of the input of OR gate is equal to 0, then here we are going to get 0, and here we are going to get 0. That means A should not be, A can be equal to 0. So both the input of your OR gates is equal to 0, then only you're going to get your output is equal to 0. Okay. So that means here this should be always 0. Let's say if it is equal to 1 and if you are going to give 1 over here, NOT gate input will become 1. So entire calculation will be wrong. So that's the reason you are going to take only 0 over here so that your NOT gate output will be equal to 1. Okay. Now, what is that? Now, output of this NOT gate is equal to 0. That means input will be equal to 1. And A is equal to 0 already and B should be equal to 1. So A is equal to 0 and B is equal to 1. Option C. Exactly. Everyone getting the same thing or any different answers? Okay, I can see people giving option C. And what about others? Are you getting the same thing or any different answers? Do you need still time? Okay, so let's move forward and let's see one more question. Yes. So consider the statements below if the output waveform from an OR gate is same as the waveform at one of the inputs, the other input is being held permanently low. If the output waveform from an OR gate is always high, one of the input is being held permanently high. The statements which is always true is both 1 and 2, only 1, 2, none of the above. So take 2 minutes of time, solve it, and let's discuss the solution. Okay, I think by now people should give answer option B, option A, option A, option A. Okay, I'm getting option A. Both 1 and 2 are true. Okay, both the statements are true. Okay, I'm getting majority answers as option A. Let's see. Okay, let's see the solution. Option A. Okay. So coming to my option A, let's see what is going to happen. So they have provided an OR gate simply. One second. So they have provided an OR gate and this is my input A and this is my input B. So A, B, output Y. And what is the question if the output waveform for an OR gate is same as the waveform at one of its input? That means if the output is equal to input, the other input is held permanently low. Let's say this is the other input which is held permanently low. Okay. And let's say if A is equal to 0, Y is equal to 0. And A is equal to 1, Y is equal to 1. And other input is held low permanently. You are getting whatever the input which was applied at the input. Okay. Let's say if this A input is held low permanently, and let's see whether it is working. So if B is equal to 1, we are going to get Y is equal to 1 and B is equal to 0, we are going to get 0. Okay. So that is what we are going to get if the output waveform from an OR gate is the same as the waveform at one of its inputs, the other input is being held permanently low. Okay, fine. It is satisfying. Now, let's say A, B, Y, and if output waveform from an OR gate is always high, one of its inputs is held permanently high. Okay, so let's say if our output is equal to 1, and what is the question? If our output waveform from an OR gate is always high, one of its input is being held permanently high. Okay, let's say if B is equal to 1, yeah, it is also satisfied. Obviously, it is going to satisfy. So I'm getting both 1 and 2. Everyone getting the same answer? Okay, option A, I can see everyone getting the same thing. Yeah, exactly. Yes. Now, let's see the next question. Now, try solving this. So you can take your time. Let me start the timer also. Okay, you can take 1 more minute, try to solve it, and get the answer. I hope by now people are getting answers. Option. Okay, this was previous. Okay, fine. Okay, so let's see the solution for it. Anyone has got the answer? Option C. Okay. Okay. Let me solve it parallelly. So what is the answer we are going to get? Let's see for it. Now, here I'm going to have, where is my pen? Let me change the color. So here my output VCC is equal to 5 volts. And if I want to glow this LED, I should provide high voltage and here I should get low voltage. That means NAND gate output is basically 0. If your NAND gate output should be equal to 0, then both the inputs should be equal to 1. Okay, that means this AND gate output is equal to 1 and XOR gate output is also equal to 1. And if AND gate output is equal to 1, then both the inputs should be connected to 1. So this should be provided to 1 and this should be provided to 1. That means this switch should be closed and this switch should be open. So if it is open only, right, we are going to get the high voltage. If it is closed, then it is going to connect with the ground and we are going to get low voltage. So that means this particular switch should be open and this particular switch should be open so that I will be connecting to the high voltage. Now, what is going to happen? I'm coming to my XOR gate. XOR gate output should be equal to 1. For that, any one of the input can be 0 and another input can be equal to 1. But we cannot provide 0. If we provide 0 over here, AND gate input will be 0 and output will be 0. So that means LED does not emit the light irrespective of the switching positions. You cannot do anything for glowing this LED, because if your XOR gate output should be equal to 1, you should provide here 0. But if you provide 0 over here, that means you're providing AND gate input as 0 and AND gate output will be 0. This will make NAND gate output to be 1. Okay. So it's option D. Yes, exactly. It's option D. Everyone understood this particular question? Any doubts or any queries in this? Is it clear? Once look into it and let me know. Okay. And what about others? Great, great. Now, the last question. Uh, Try this. So take this particular question as your assignment, and I will enable the chat of WhatsApp group. You can basically, or let's say we will discuss this particular solution in our next session. You can take your time for this particular question. You can take whatever time you want for solving this particular question, and we can discuss the solution in our next class. Okay. So in our next session also, we are going to deal with a few other questions. Okay. Yeah. Please note this particular question or take a screenshot of this. And this is a small assignment for you for today, and try to solve it. And in our next session, we will try to have the solution. And how many of you are comfortable with key maps? Please let me know in the chat box. Okay, I think most of you watching over here knows key maps, right? About everything about key maps, right? Yes. So let's do one thing. In our next session, we will start with problems related to K-maps. Let's solve problems related to K-maps. And we'll see little bit theory about K-maps. Like we have something known as essential prime implicants, redundant prime implicants. Those will also be important for solving K-map related problems. Okay. That we will discuss, and we will start doing problems related to K-maps. Okay. Yes. So that is a plan for upcoming sessions, which will be on Monday.